Hello, everyone, and welcome to another Directions Mag Geospatial webinar, today sponsored by our friends at Hexagon. I'm Barbary Duke, Managing Editor here at Directions Magazine, joined by our webinar producer, Lynette Qualia. We encourage you to stop by and read new feature articles, daily news, and of course, watch more webinars over at directionsmag.com. Today, we would like to welcome Daniel Balog. He is the R&D Director at Luciad, part of the Hexagon family. We are looking forward to learning more about smart monitoring and what that looks like in 3D and panoramic views. Daniel's got some really fascinating things to share with us today. Daniel, welcome.
Thank you so much, Barbary, for that introduction. Okay, thank you very much. So thanks everyone for joining, and thanks for that. I'm here today to talk about dynamics with panoramics. Topics for today would be panoramic images. I'm actually very thrilled to be able to present this. I'm very honored that I'm able to present the work that our product development team has been working on very long for a while, and I think this is one of the most exciting features that we've built in a long time. But before I get into the actual panoramics, I just wanted to give some context for people who may not be familiar with what we do. So one of the products I want to focus on today is called LuciadRIA, and LuciadRIA is developed by us internally. It's a JavaScript, a browser-based JavaScript library that you can use as building blocks to create your own end-user applications. What you can see on your screen right now is a typical application that you could develop if you had the right data sets and if you were to combine them together into one coherent picture. That's actually one of the things that we at Luciad, so we're part of Hexagon, we at Luciad like to focus on is basically creating an application where a lot of different types of data can be combined in a single coherent view. For instance, in this case, this San Francisco data set, we have our satellite images, we have our elevation, we have our point cloud data, we have mesh data, as well as buses driving around in real time. We can even do things like on-the-fly expressions that show you, for instance, the 3D distance between a bus and a particular point in the data set. Now, when we bring everything together, the cool thing is that you can do more if you were to take each data set. Like, for instance, all these data sets and put them together, we get new analytical insight. For instance, a cross-section of a bus route to show vegetation in the area. Really, this is the core of what we are trying to bring with our product to make sure that they run as smoothly as possible in a browser and just get a compelling application with amazing visual quality as well as functional capabilities. So the new feature that we implemented is called the 360-degree panorama feature. And before we dive into that, just quickly some context to that. So a panorama is basically derived from Greek words pan, meaning all, and orama, meaning vision. It really the definition is basically a wide-angle view or representation of a physical space. Now, historically, this was mostly used in paintings where you would want to get more information on a very wide painting. But typically, when we talk about panoramas these days, we're talking about a digital representation of the world around an observer. In the case of 360-degree panoramas, we're talking about a full 360-degree sphere around an observer where you get information for every single direction around that observer. Maybe also a cool little trivia, the word panning, meaning moving around a camera, is also derived from the same words. All right, so how do we actually get this type of data? Well, there are so-called reality capture devices that let us take captures of the world around us, and they come in all shapes and sizes. For instance, here I have the Black 360, a terrestrial scanner. When a terrestrial scanner, the prime property is basically that you put it down, usually on a tripod, you push a few buttons, or in this case, one button, and it starts surrounding its surrounding environment while standing still. It's kind of the key point of a terrestrial scanner. You have another class of device called the mobile scanners, which let you move around while it's doing a scan. So it's kind of the difference between the two. And within the mobile scanners, you have subclasses. So you have portables, in this case, a backpack, which is scanning as the operators moving around. You also have automotive, which are extremely popular these days because you can capture a lot of information very quickly, basically. So as your car is moving around, it just automatically captures everything around it as long as you're driving, basically. But a fourth class might surprise you these days. We also have smartphones. So many of you will have smartphones right in your pockets, and you should know this is actually a fantastic source of 360-degree panoramic images. By using all the sensors of a typical smartphone, like your gyroscope and your magnet, as well as your GPS location, software can typically stitch together multiple pictures and get the correct heading and location, and we can use that metadata to do very cool things. Now, when you actually create a 360 panoramic image, you would end up with something like this. So this is a 360-degree photo, and it basically gives you information for every single direction around an observer. In this case, you could even say that it wraps around from left to right. So the leftmost pixel is basically next to the rightmost pixel. And the top and the bottom are basically the top and the bottom of around the observer. Now, you might already have seen this type of image, and it's already fairly useful to have this kind of information. But in order for us to use it in an application, we would have to reproject it. So when we talk about projection, and I know a lot of you will be part of the geospatial industry, you might already have heard of projections. You might think, hey, is this the same thing? Well, it actually is. The thing is that panoramic images have their own class of projections, but it boils down to the same thing. You take an image, and you want to make sure that you can analyze it in 3D space. So an example of that would be the equirectangular projection, where every single pixel coordinate, so every single x and y coordinate, is mapped directly to a longitude and latitude of a sphere around an observer. And by doing this, you get kind of all the directions that you need, which you can then use within the context of 3D space. Now, why do we have multiple projections? Well, many projections have many different properties. For instance, one of the downsides of equirectangular is, despite the fact that it's very simple, the top and the bottom have a lower quality because you kind of have the latitude being clamped at the top. But another type of projection could be the cubic projection, where we take 6 different sides to a cube, and we don't have that problem, even though it's a more complex projection. Now, within the domain of panoramic images, we found that out in the wild, these two projection types cover most of what you would find produced by a typical device. So we support both of them right out of the box. Now, when talking about 360-degree panoramic images and also applications, you might think, you might have a preconceived notion of what a 360-degree panoramic image viewing app would look like. For instance, it could look something like this, where I'm looking at an image, I can look around, and I can click somewhere to kind of move to the next sensor location. So I've taken these images at specific locations in space, and I can navigate between them and look around. This is kind of what we've come to expect from a 360-degree panoramic image viewer. And of course, this is exactly what we can do. But we wanted to take it one step further because this wasn't enough to us. So we kind of thought about what makes us unique and how can we use our uniqueness and our vision to also apply to panoramics. And we kind of got to thinking about it. What is the secret ingredient about Luciad? Well, as I explained in the beginning, the whole point of our philosophy is that we want to have one single operational view where everything works together. So if you have terrain data, imagery, vector, mesh, or point cloud, you can place that in a single coherent operational view, and all of your data sets will work together. So when we got to the whiteboard and we were basically trying to come up with solutions to panoramics, we thought, well, why not do exactly the same thing? And we did just that. So if you have an existing application and you want to augment it with panorama data, you can do so. Or if you don't have any application at all and you want to start from scratch, you can start getting multiple different data types together and still create a coherent application that benefits from all of them put together. And one direct implication here is that we don't couple the camera of the viewer to the actual location of the panorama. we fully decoupled it, which also has a couple of advantages that I'd love to show to you in a demo a little bit down the line. Also, we want to make sure that you can combine everything on the fly, which is something we typically do in our applications. Because when you combine things on the fly, you can have dynamic parts of your data that updates other parts of other data. And by working together, you can create more compelling applications that are more useful. And again, I have a couple of cool demos a little bit later on. But the key point is this. We want to make sure that when you combine multiple data sets into a single application, that the sum becomes greater than the individual parts of those components. And by working together, we can achieve more visual insight, analytic insight, and processing insight for this type of data. All right, so that was the explanation part of this demo. Let me just move on over to a couple of use cases and demos. This first demo is a data set. This is actually our own office building in Belgium. We have the exterior of our office, as well as the interior, a 3D architectural CAD model of the building. And on top of that, we also have 360-degree panoramic images, of course. So when we start looking at this data set, we can look at it from the outside. It's at the right spot on the world. It's georeferenced. We can also press this button on the top to fly inside the building. So when we do that, we get all of our typical controls. We have a couple of blue hexagons on the floor. We can navigate around. And as we move around this corridor, we can see the first interesting happening right here. Oh, by the way, if you were wondering what I look like, this is me. So hello. Oh, this is actually a 3D scan of me. So this is a 3D model of me and a colleague of mine that I've added on top of the panoramic imagery. And I can prove that by opening up my layer controls and making me and my colleague invisible. And when I do so, you can see what the actual image looked like when we captured it. So already we're kind of combining 3D with the panoramic imagery, and that allows us to do more than we could do before. When I turn around, we have our little art gallery for visitors, and I've added a vector data in the form of icons that I can interact with that pops up a balloon. So already 3D data and vector data combined on top of the panoramic imagery. All right, moving around this corner, we have two more of our colleagues. But here, something interesting is going on. Let's see if you can spot it. So again, just remember, we've taken basically captures of our office and then created panoramic images. And now I've taken 3D scans of my coworkers and I've put them behind this table over here. And again, just like with me and my colleague before, same story. So these are 3D data sets, not part of the original data set. I can make them invisible. But just think about it. I'm looking at an image. I've placed a 3D object inside that image, and it's appearing behind the table. So this is kind of the power that you get when you try to combine multiple data sets together and you have them work hand in hand. All right, I just want to show off one more cool thing as we move to this specific vantage point. So over here, I have two more of my colleagues, which I have direct line of sight of. But I also have Sophie over here, who I can see through the glass. You can't see me or the other person, Dirk, next to Sophie. But using our styling capabilities, I have this button over here that I created so that I can apply an outline style on anything that's not visible, basically giving me more situational awareness of my surroundings. So when I look around, anyone I can see directly does not have this outline applied, but anyone I can't see will have this outline applied. And as I move around, this dynamically updates and changes based on where I am currently located. So just by having all these data sets put together and working together, we can take our existing styling capabilities and really create compelling applications. Now, I already talked about the concept of decoupling the camera. And I just wanted to prove the point here. So this is exactly the same data set. This is our office building 3D architectural model. It's fairly low detailed, but everyone is still there. So you have the 3D scans of the people. But this time, I've kind of cut through the roof, and I'm just looking straight down from above. And when I do so, when I'm not inside the panoramic image location itself, and I'm just using regular camera controls to navigate around, I can do some pretty cool things. Like for instance, I can zoom in here, and I can select one of these panoramic images and just visualize them as is. And when I do so, I'm taking my existing 3D data and I'm augmenting it with the panoramic image that I've selected. And this lets us do a bunch of cool things. For instance, I can just zoom out. I can see the direct line of sight of what the sensor was able to see at the time that I actually made the recording. For instance, if I select another one, I can see what it was able to see at that point in time. And the second thing is I can take this low detail architectural model and I can make it more detailed by augmenting it with the panoramic image data, which I think can be used for a lot of very compelling applications. So again, I want to point out, we don't actually make end user applications. These are all examples of what we could do, but it really is something that I think is unique within the domain and that can bring forth a lot of potential for interesting applications. Something that I think is very cool. Here we have an airborne data set, which is the city of Lucerne. It was scanned by flying an airplane over the city in Switzerland and then reconstructing it in 3D. What we also have in this data set is panoramic images, which were taken using a mobile scanner at various points around the city. So I just want to focus on this area specifically right here. So these two data sets were taken completely separate from each other, not even on the same day or the same year, but I can still have them work hand in hand, and I can have the photos of the panoramic imagery work together with the 3D. Like, for instance, when I make a measurement inside the 360-degree panoramic image, I can make a measurement based on how tall the structure is, how far it is from the specific point, and I can do so using the photos as a reference. And by the way, this is done in 3D. This is an actual 3D measurement. So when I leave the panoramic, the measurement is still there. That's because we're only using the photos as a reference, but we're actually measuring in 3D. So this already gives you a couple of perhaps ideas on what our capabilities are. But we can go, of course, further than that. Underneath this bike parking lot, I actually have an underground data set. So let me just enable my styling from the previous demo, and we can actually see under the data set. Now, this is not some trick. This is actually a 3D data set that's lying under the ground that we just can't see because it's being covered up by the ground. As I move around, you can see various vantage points to the underground data set. I can also leave my panorama. You can still see it. But wouldn't it be great if we could dynamically alter the world around us to make sure that we can see this data set? Well, that's why I have this little dig button that we created using our API. When I click it, I get this little purple bounding box that I can move around in 3D space. And when I click, it digs a hole into the ground on the fly. So now I've carved a hole into the ground in the photos. I've exposed the tubing and the sewage pipes under the ground. And on top of that, I can now select them and get more information about what's under the ground. Now, again, this is not some trick that we're doing. We've actually carved a hole into the ground. So I can show that by leaving the panorama and looking at it. And now we're actually seeing what the hole is that we've covered. So let me just turn off X-ray vision for a second. And we can now just look at it, click on it, get metadata. And because we can do this in 3D, we can also do this inside the Panoramics. And we can do all of this on the fly without any pre-processing. So that's pretty exciting. All right, another demo that I thought was fairly cool. What if you take moving buses on top of the same data set? So again, we're in Lucerne. And just ask yourself, what do you think would happen if I were to zoom into one of these panoramic data sets? Well, the thing is, if it works for static objects, it'll also work for moving objects. So in this case, the buses will be occluded by the buildings. And as it's moving around, it'll actually be occluded by this tree line over here. So again, this is kind of the power you get when you really try to combine all the data types that you have into a single comprehensive view that makes them work together as a whole. You can have things like this where occlusion is optional and can be used on top of the measurements. And again, everything works whether it's dynamic or static because it fits into our existing API. So again, another viewpoint as this bus is moving over the bridge. We have another bus on the left, the purple bus, which is currently disappearing behind some buildings. And again, you have to understand this is actually an image you're looking at, but you're using the 3D to calculate occlusion. Everything just kind of fits together, and it gives you more information than if you were to just have the panoramic images by themselves. So I think this is pretty cool. Okay, one more demo, which is actually my favorite. So I'm really happy to be able to show this. This is a smart site, which was created using well, it's actually a 3D mesh of a smart site, of course, it's digital, which was created using a terrestrial scanner, which was put on several spots that you can see. And then using that, we took the point cloud and we processed it into a multi-level mesh. Now, same story as before, we can look at it. Looks like a very interesting device there on the middle. So let's just move into it, and same story as before, we can navigate around. This data set was actually fairly high quality, so I was very pleased to receive it. When we move around here, we can get a little bit closer to the structure in the middle, and we get a very nice close-up of what's going on. But we also have metadata inside this 3D, and by using the metadata, we can apply selection operations in 3D and get metadata about what we've selected, like what the type is, what the capacity is, when the last time was that it had maintenance. We can select something else. There's also some buttons, for instance, to get more details or to report an issue. All of this is fully customizable using the API. It's just an example at the end of the day, but it could be integrated into a larger application, of course. And again, just as I'm moving around, this is not some trick in 2D or so. So as we look around in this nice little panorama on the top, we can select one more of these containers. And then when we leave the panorama, it becomes apparent that, again, we're not doing a selection in 2D, this is a selection in 3D. This is an actual 3D data set where we've selected something, we've looked at the attributes, but we can also use the panoramic images to get more details about what it looks like in real life. So again, I'm really excited that we're able to bring all of this together. And yeah, I'm just really proud of our team for having been able to accomplish this in our last release that we just brought out. And also here, I've changed the X-ray button to inspect components, but this kind of gives you an insight on which of the parts of the mesh have metadata attached to them in this case, which gives you a bit more insight on the actual data set itself. Okay, so to kind of wrap up here, our 360-degree panoramic imagery just released in LuciadRIA. We support multi-leveled data sets, of course, because you want to stream everything over the web. By default, we support rectangular or cubic projections, though more could be added using our LuciadFusion component. Of course, we support smooth transitions because that's what people expect. But on top of that, if you have 3D data set and you can combine your 360 panoramic imagery with your 3D, then you can also do measurements in 3D. And you can also have full camera control, so you're not tied to the classical moving between the points that you've actually scanned. And on top of that, our typical benefits from LuciadRIA, we can combine multiple different types of data coming from multiple different types of sources, so not just one server that's feeding us everything, it could be multiple services. And of course, if you have multiple data sets, even multiple projection types, we can combine all of that in one coherent view. And finally, one thing I didn't mention yet is the support for non-referenced panoramas. So just in case you have a device that doesn't register GPS coordinates or you can't reference your data set for whatever reason, we can also still visualize it in a 3D view. Okay, with that in mind, I still think we have some time for Q&A. What do you think, Barbary?
Absolutely. So I think we can sneak in a few questions, and thank you so much. Man, this is really cool stuff with so many interesting applications far beyond what you showed today. So let's start with a question. Is there any way to play with this solution with some dummy data or practice data?
Yeah, absolutely. So right now we have our dev platform, dev.luciad.com, where we just updated our sample codes to the latest version. So if you head on to dev.luciad.com, there's a button that says samples where you can click on Panoramics. and you'll get the panoramic sample where you can play around with it yourself.
Perfect. Next question, which steps do you take to go from a reality capture device to a web application?
Okay, so the thing is when capturing reality capture devices, when using reality capture devices, there is definite steps in for going to acquisition. So actually having the operational part of it, sending out people in vehicles or with backpacks, and actually getting the results from them. But once we have those results, we have been doing testing on as many different types of equipment as we could. We have a server-side component called LuciadFusion that can take care of the heavy lifting of actually processing this and also delivering it using content delivery. Mm-hmm. So the only part that we don't do is the actual, creating the device, obviously, because we're software, not hardware. But once you have the acquired data, there's a couple of standards like E57 that we support right out of the box. So if you can give us an E57 file of your scan, then our product can pre-process it for you. And it's just a matter of a few clicks of actually getting it into a web app.
Nice. Someone would like to know if you have any examples of merging urban forest and street tree data.
Urban forest and street tree data. I'm gonna go ahead and, because I'm not entirely sure what that refers to. I assume if you have two separate data sets, for instance, urban environments, and also completely separate from that, trees.
That would be my guess.
That would be my guess. Case then and both of those data sets are georeferenced, which would be the big clue here. You could just add them into a single view, and LuciadRIA should take care of making sure that they're displayed at the same time. If you have panoramic images on top of that, then you can kind of choose what you want to do. Do you want to visualize the trees above the images? Do you want to visualize them below? Like, I've had a question before where one of our prospects asked us if we could do a visualization for a tree line that did not yet exist. So they would do a simulation of trees as they would grow in the next 20 or 30 years, and they would deliver that mesh to us. And they asked us, can we see this tree line inside the images that currently exist today? And we said, yes, of course. You just need to have the 3D data of the current situation, the simulated 3D of the trees, and then the panoramic images, and you should be pretty much good to go.
Awesome. Folks are curious about spatial data types that are okay. So shape, KML, others.
Yeah, if you want more detailed information, so go to dev.luciad.com is the first thing that I would recommend. We have all of our API documentation online. You don't need to create a login. You can just access it. We have samples, and we have white papers, and that will give you much more detail than I can present in a few minutes. The thing is that we have server components as well. And for LuciadFusion, we support over 200 formats, and I cannot list them right now. But for our client components, typically we prefer GeoJSON, KML, let me think. Yeah, just of course, any raster format that just has some geo information, like a JPEG with bounding boxes, stuff like that. Yeah, generally I would recommend using a server component that can give you data with open standards, which is exactly what we do with LuciadFusion.
Excellent. So how are you dealing with scalability?
Yeah, so scalability, I think, is a twofold question. So you have server side and client side. Everything I showed you today is client side. On the client, typically we support multi-leveling. So we haven't gotten our hands on a gigapixel or petapixel image data set yet. I'm hoping to get one soon. But once you slice that up and you have multiple levels of detail, you can pretty much just scale to how many you want. If you're talking about scaling the amount of images, LuciadFusion has capabilities of doing spatial indexing of the metadata of panoramic images. So if you want to basically have 1 million panoramic images in your application, you would use LuciadFusion to process it into a spatial database such as PostGIS, and then the client would query only the areas that are close to the observer, which is also fully programmable, of course, but that's basically the way I would do it.
Awesome. Well, Daniel, we are out of time.
Oh, okay.
But folks, it goes by fast. And we've got several questions still coming in. So folks, we are keeping these very safe, and we'll pass them over to Daniel and his team. And I know that they will be excited to follow up with you personally. So keep an eye on your inbox, folks. We will share the links that he talked about today as far as some examples. If you're excited to go ahead and start digging in, head over to that's dev.luciad.com. But we're going to send that to you via email, so you don't need to write that down or remember it. But if you're excited, head on over there. Thanks again, Daniel. We really appreciate you sharing your expertise and all those cool models. It's exciting stuff that's possible with the software. And thank you to our audience. Yeah. Everybody go make it a great day. Tell a friend about Luciad and Hexagon and Directions Magazine. We hope that you'll make a difference out there in the world. Thanks so much, everybody. Bye-bye.